Okay, this is the wood stove that I've been working on, and actually installed it over a year ago, and was doing modifications this year to improve my combustion efficiency and to extract more hot water out of the flue stream before it exited through the roof. I had some problems with some well, not good enough combustion. I have added fire brick to the inside lining. I had tried to induce a draft at the same time, in attempting to extract a lot of the heat from that. On initial startup, you would not be hot enough, and I would have to try to make it go without a lot of attention. That is, I couldn't directly feed air to it, so I put a flue draft fan on at the top, which helped enormously to help induce a draft to get the flame going. However, in the beginning, there still isn't enough direct air flow. The two air intakes just feed through this fireplace door, is what it actually is, and it's been attached to an old metal box freestanding wood burner that didn't have doors on it at all, just a pull chain. Pretty common model, I think, from the time 25-30 years ago, actually, when I had seen these around, and picked this one up at the Habitat Restore for $25. But the doors I had purchased for a project about 30 years ago to do essentially what I'm trying to do again now. What I had done was look at the stoves on the market and found that the secondary air intakes were feeding through preheated tubes in the back, which I had added this 1-inch diameter black iron, and you can see there that there are a number of small holes drilled in that end on the other side. That has helped a fair amount with having secondary air, and I was trying to use this copper pipe that drew air from up under the tank, fresh outside air, to also clean the glass, as well as that to keep the glass wash. But it's also had a tendency to collect creosote and smoke because of the heat of the fire chamber and the relatively coolness of the doors, which unfortunately they get enormously hot as well. So what I had done to not only induce the draft, I had added a pump over here. This is an old air pump for a air mattress, and when it turns on, it's also enormously noisy, so I don't use it except on startup and when I want to really gas up the fire. So what I had done is complete the fire brick around the outside perimeter, which completed means there wasn't any fire brick to begin with. There was a refractory base, which I added a little bit of thickness to hold the brick in a little better. And then in the most recent permutation of this, I added this top chamber and actually put a piece of metal underneath the opening across where the flue draft was. I thought with my draft fan I could draw my smoke through this chamber, which was kind of inspired by the rocket stove builders that indicated that if you could get a hot burn chamber, and I looked at different ways to create an air channel or a burn chamber. What I had not been able to do was get this to really work the way that I had hoped that it would. But I'm looking for ideas from the stove builders out there that might suggest that, I'm drawing the smoke in. I'm trying to create a little bit more of a turbulence, the right kind of the vortex I've seen trying too hard and other builders doing at this point. Seems like I would like to find a way to, and I could move this secondary air, to where it actually fed a vortex that would be inside of this cement, or this fire brick chamber. And you can see it actually then feeds directly up into this secondary chamber that has some copper coil and some straight line copper, and the smoke coming up through there and moving across this top section and then exiting through the flue into this secondary chamber. That is something I did build 30 years ago, that has 3/4 inch copper pretty well lining the entire outside of or the inside, I guess, but out to the outside edge of this. I had used it only briefly when it was put on top of a stove. It would cool the smoke so much, and the chamber was so big that it was very difficult to create a draft. I had made a 6-inch hole in the bottom of it and a 6-inch hole in the top with a cast iron flue collar on that. And as you can see, I've cut the top of this tank off and then cut some slits into the next section, the lower section, so that I could just jam that over that and fill this with furnace cement. Not being a welder, as you can see, most of this has been working around refractory cement and going into this coil that's in the flue pipe. Actually comes in the other direction, and as you can see, these are the copper pipes that feed the chamber inside the fire box above and then come off of this tank and go back to my pumping system. So what I really want to accomplish, I think, at this point is, I was looking at P. Pitty's design, where he had kind of built a box like this and having a combustion chamber and a flue stack. I'm not going to have anywhere near 18 inches. I'm thinking it would take a major modification for me to make a stack that would work in that fashion. I'm trying to get some ideas with regards to how I might build a better chamber. I had thought about trying to put something across this surface and having a downflow, and the fire built just in this section, and divide these off and the downflow and back up using fire brick. I still might go back to that, because this chamber here could play a role in that kind of a system. What I want to get is that complete combustion. I still want as big a firebox as possible, and I think that once you get something like that up to temperature, you can still get a complete combustion, and then you can very efficiently extract your heat off of that. Now, as you realize, that this is all done in copper, and there's discussion of the corrosion possibilities and how it might be in stainless steel, but for me, I thought it was, at least within using the items that I had around, and including items I had around, is an oven thermometer. As you can see, some of the lines are messed up, but it will give me a flue gas temperature at the outlet that I can tell that I have running around 120 or 30 at the hottest. I'm doing a pretty good job, considering I'm having a pretty good fire in here. However, I am still having more smoke coming out the chimney than I would like, so I really want to improve the combustion capabilities of this part of the stove, using more of a rocket technology and the draft-inducing fan that might help those. I need a way, I think, to get the wood to actually slide downward as is commonly used, so that the fire stays at the end, and then it's all more concentrated in the heat, and getting the secondary air as a place to feed in to it. So, using that I've got some ways to actually heat the floor of this small shed. At this point, it's a 24 by 16 by 24 shed, but there is PEX tubing in the floor over 1.5 inches of styrofoam, so it is a very large heat sink. But I'm also able to send heat up to the house at this time with some cables or some pipes that have been put underground when I was putting down cable. Now, from this angle, sorry about the moving around, you can see that there is a damper on the back. So inside of this tank, there's a 6-inch pipe that with holes cut in the bottom of it and in the top of it. So when this damper put on a piece of threaded rod is closed, it forces the flue gases out into the outer body. The idea was that I would have a better draft, and when it got burning hot, then I would send it out through the outside, and that's worked pretty efficiently for me. And then these pipes then come back and feed into the same place that my solar feeds into. These are the current temperatures of the solar heating system coming off of the heater. That says 91 degrees, and then coming out of going into the floor, it's 80, and coming out of the floor, it's 76. That's because there's actually a 80-gallon storage tank in here that is heated by, there's the pump from the solar, heats up the water in the 80-gallon tank, and then there's the differential controller with the green light on up there. And so then when the water in this tank is heated, then the pump up there will take that heated water and pump it down and into the floor, or actually the valve there can switch it so that it can go up to the house now. I have a radiator up there and just testing that system. And there's a return line, and then that's the return to the wood stove right there. And so I switch a couple of valves, and then that system is able to heat the floor or the hot water tank alone if you like it, if you don't need it elsewhere, or send it to the house. The solar collector was originally designed to be a test model that I would like to be able to use more solar heat and send that up to the house. And basically I designed this stove and insulated it extremely well so that there wouldn't be too much heat loss. I've got some pictures of that, putting rock wool between those and the fire brick. Helps it to be pretty tight. Actually, it takes quite a while to heat the shed up using it because it has to send the heat into the floor. The idea would be that the extra heat that is left over from this fire would heat the shed, and the primary heat would be transmitted